right, students and families, this week our homework is going to focus on fractions. That's what we've been working on for the last several weeks, and also taking a look at relating fractions to decimals, and putting decimals on a number line. Tomorrow, our homework that is due is going to be questions 1, 2, and 3 of the homework packet. And I'm going to go over a little bit about the expectation and the concepts for each one of those problems to hopefully help you out a little bit. So let's go ahead and take a look at that first problem. If we take a look at the first problem, the concept that's being taught to you guys, or the concept that you're expected to know, is how to take a fraction and write it as a sum of fractions. In other words, being able to take a fraction, for example 4/6, and knowing what fractions can we add up together to make 4/6. I mean, it can be done in several different ways. One way it can be done is by taking unit fractions and then adding them up. Unit fractions are fractions in which the numerator is always a 1, and it represents one part out of a total number of parts. So we could add 4/6, we could find the sum of 4/6 by adding 1/6 and another 6 and one more 6 plus one more 6. So if you notice, I have 1/6 plus 1/6 plus 1/6 plus 1/6, and if you add these all together, you get a sum of 4/6. So that would be one way to solve that problem. Another way to solve that problem would be to add different fractions together to equal 4/6 that are not necessarily all unit fractions. So for example, I could add 2/6 and 2 more 6 and still get a total of 4/6. Or I could take 1/6 and add 3/6 and still get a sum of 4/6. So that is the concept that we are looking at in the very first problem. I hope that helps you to be able to answer this question. On number 2, this is our standard where we were learning how to add and subtract fractions. When we add and subtract fractions, let me give you an example. Let's say we were going to add 2/3 plus 3/3. When you add fractions together, the only number that is going to change is going to be the numerator, which is the top number in a fraction. The bottom number is the denominator. It equals the total number of parts being added, and that never changes. So if we were to be adding 2/3 and 3/3, that equals a total of 5/3. Same goes for subtraction. If I were to give you 4/8 and asked you to take away 2 of those eighths, well, if I do 4 minus 2, I get a difference of 2, and my denominator stays the same. It stays an 8, because we are dealing with 8 equal parts. So that's what adding and subtracting of fractions are going to look like. One of the things that might help is to use a model. So I know that if I'm taking 2/3, I'm going to make a model that represents thirds. And because I'm adding 2/3 to 3/3, I'm going to first shade in 2 of these thirds. I've shaded 2 thirds. I need to model the fact that I need to add 3 more thirds, but I don't have enough over here. I only have enough for 1 more third. So because of that, I need to make another model of thirds. I'm going to label each piece a third, because each piece is 1 out of the 3 parts of that whole. And so to model this problem, I'm taking 2/3, which I shaded over here, 2/3, and I need to add 3/3, so that would be 1, 2, and 3/3. Now when I look at my model, I can count all my shaded parts and know that I have a total of 5/3. which is also the same thing as having an entire whole, because if I've shaded 3 out of 3 equal parts, I've shaded that whole thing. And I have a leftover 2 out of 3 parts, or 2/3. So I could write 5/3 as being equal to 1 whole and 2/3. 1 and 2/3, that's a mixed number. Now if I'm subtracting, I could represent that in 2 different ways. I could start off with 4/8. So I'm going to go ahead and make a model of eighths. I know it's not very neat, it's kind of hard to do this. And because I'm starting with 4, and I'm going to label, well, let me label each piece 1/8. Because I'm starting with 4/8, I'm going to go ahead and shade in 4. Okay. And then I could show that I'm subtracting 2/8 by drawing another model of eighths. So I'm going to go ahead and do that. Excuse me. Okay, and I'm for time purposes, I'm not going to label each one an eighth, but we need to know that each one of these represents an eighth. And I'm going to show that I'm taking away 2 of those eighths by, I'm going to go ahead and just shade in 2 of those eighths. And then if I wanted to find the difference between these 4/8 that I shaded and the 2/8 that I'm taking away and that I shaded down below, all I would do is count up how many more pieces would it take to get from these 2/8 to the 4/8 that was shaded here. So if there's 4/8 shaded here and I have 2/8 here, it's only going to take me 2 more eighths to get to this amount. Therefore, our answer would be 2/8 when we subtract those 2 amounts. So hopefully that will help you with solving number 2. On number 3, kind of goes back to what we did. On number 1, the adding and subtracting of fractions, we need to know that if I have, let's say, 4/6, that would be the same thing as 1/6 plus 1/6 plus 1/6 plus 1/6. But it's also the same thing as having 2/6 plus 2/6. And it also means 4/6 is also the same as having 1/6 plus 3/6. So you will need to have that knowledge about adding fractions and finding the sum of fractions in order to be able to help you solve the problem on number 3. I hope that helps. Thanks.